Welcome back. Today, we're gonna pull back the curtain on a secret ingredient that is, quite literally, powering your world. It's hiding in your phone, it's in your car, and it might just be the key to the future of our entire planet.
So I want to kick things off with a bit of a puzzle for you. What on earth could your tiny little wireless earbuds possibly have in common with a multi-million-dollar cutting-edge F-35 fighter jet?
Believe it or not, the answer is just one single, unbelievably powerful material. This is the story of neodymium, the unsung hero that secretly makes our modern lives possible.
All right, so let's dive right in, starting at the beginning. Part 1, the rare earth myth. Okay, so the very first thing you need to know about neodymium is that its group name, rare earth metals, is completely wrong. It's a total misnomer. These things aren't actually rare at all. In fact, neodymium is about as common in the Earth's crust as copper. The real problem is that it's, well, kind of antisocial. You see, unlike gold, which likes to clump together in veins and nuggets, neodymium is scattered super thinly all over the place, making it incredibly difficult and frankly pretty toxic to purify.
So that brings us to part 2. If it's such a pain to get, why do we go through all that trouble? Well, because neodymium has an incredible superpower. It creates the strongest permanent magnet known to humanity.
This magic recipe was figured out way back in 1982. By mixing neodymium, iron, and boron, scientists created this compound. Now, its unique crystal structure is the key. It forms this super rigid cage that basically locks all the magnetic fields of its atoms into perfect, powerful alignment.
And that special structure gives it a really important property: coercivity. Yeah, it's a fancy word, but all it really means is an extreme resistance to being demagnetized. Think about it. A normal iron magnet can get weakened by a little bit of heat or another magnet. But that atomic cage in a neodymium magnet makes it stubbornly, almost unbelievably powerful.
Just how powerful are we talking? Well, get this. A single coin-sized neodymium magnet can lift 10 kilograms. That's about 22 pounds. I mean, that is an absolutely insane power-to-weight ratio.
And to really put that raw power into perspective, here is an actual safety warning you'll find online. If two large neodymium magnets slam together with your hand in between, they will shatter your bones. Seriously, this stuff isn't a toy. It's industrial strength force that you can hold right in your hand.
Okay, so it's incredibly strong, we get it. But why does that matter so much? Well, that brings us to part 3, shrinking our world.
Here's the crucial idea. Stronger magnets let us build way smaller, but just as powerful motors. Before neodymium came along, if you wanted a powerful motor, it had to be huge to fit those big, weak iron magnets inside. Neodymium completely changed the game.
All of a sudden, motors could shrink down to the size of a walnut without losing their punch. And this miniaturization revolution is literally everywhere. It's what powers that tiny arm in your old hard drive, flicking back and forth 50 times a second. It's what gives your earbuds that amazing concert hall sound. And, most importantly, it's right at the heart of the green energy transition, driving both electric vehicles and those massive wind turbines.
And when I say massive, I am not kidding. A single direct drive offshore wind turbine, one of our best tools for fighting climate change, needs 2 tons of neodymium magnets just to work. 2 tons.
But, you know, every hero's got a weakness, and neodymium's is a really big one. And that leads us to part 4, a hidden weakness.
We all know the story, right? Every Superman has his kryptonite. Well, for our supermagnet, that kryptonite is surprisingly simple. It's heat.
This all comes down to a scientific principle called the Curie temperature. It's basically the point of no return, the temperature at which a magnet permanently loses all its power. For a standard neodymium magnet, that point is just 80 degrees Celsius, or 176 Fahrenheit. An EV motor gets way hotter than that, which means a standard magnet would just die. So engineers had this huge problem on their hands. How do you use this amazing but heat-sensitive magnet inside a really hot electric motor? Well, the solution was to add another secret ingredient to the recipe, a second truly rare metal called dysprosium. Adding just a tiny bit of dysprosium makes the magnet tough enough to handle the heat, but it also makes it a whole lot more expensive. And that cost, that dependency, leads us directly into our final chapter, where science crashes right into geopolitics. Part 5, the global supply crisis. So why is this even a crisis? Well, remember how I said purifying neodymium is a toxic process? The refining involves dissolving rock in acid, and a nasty byproduct of that is radioactive wastewater. Because of those environmental dangers, most Western countries just stopped producing the stuff back in the 1990s.
And this is the result. China stepped right in to fill that void. Today, China controls somewhere between 70 and 90% of the entire global supply chain for rare earth metals. That gives them immense geopolitical leverage.
Because of this situation, the US and many other nations have officially declared neodymium a critical mineral. That's a formal way of saying it's absolutely essential to the economy and to national security. Let's be clear, if the supply from China were ever cut off, production of everything from F-35 jets and iPhones to life-saving MRI machines and the EVs we need for a green future would grind to a halt.
When you really take a step back, it's pretty clear. Neodymium is that quiet, unsung hero that made the miniaturization of our world possible. It's what took us from a clunky, analog past to the sleek, powerful digital world we all live in today.
And all of this leaves us with a huge, critical question for the future. As we race to build a green economy that depends on electric vehicles and wind turbines, can we really afford to be so reliant on a single source for its single most magnetic, most essential ingredient?